afternoon once again, ladies and gentlemen. Standing before you is your honored MC for the second session, Major Mwenze Lindy from the South African Air Force, Senior Air Traffic Controller all the way from Cape Town, the United States of Cape Town. I mean, when I got to Gauteng province, as you can see, I'm wearing a jersey, and some of the people said to me, "Why are you wearing a jersey?" I said, "You know, when I see a shadow of any kind, I just feel cold because Cape Town is cold." Thank you once again. All protocol have been observed. I'd like to welcome you to the second session. And the session for today is about sharing recent development in the use of integrated applications and research for social benefit. I am not the moderator for this session. I will, however, be introducing the moderator shortly. In the meantime, I would like to advise all of us and kindly request that should there be any comments or questions arising during the duration of the session, you please forward them to the Slido platform. I don't know if everybody has the platform or the link. And then I believe that the moderator at the end will be able to give the opportunity for Q&A. Thank you. What an awesome conference. I am so proud of South Africa and what we have achieved so far. The unveiling of the rocket out there, I'm sure all of you were amazed. We're not amazed. Yes. Can we also just appreciate what South Africa is very much capable. One of the key points from the speakers this morning, one of the key points was that South Africa is very much capable, and we have the infrastructures to develop our own space technologies. And what we have witnessed out there is just what has been said. And really, I am proud of us as South Africans. And as the youth of South Africa, we are looking forward to a greater future. The future is really bright. Our moderator for today, as I'm introducing him, I would kindly request all the speakers to step forward and take a seat in front. The moderator for this session is none other than Dr. Moses Chong, the Chief Scientist and the Research Group Leader of the Precision Agriculture Group right here at CSIR. Ladies and gentlemen, may we please welcome the moderator, Dr. Moses Chong. And may the speakers please proceed to the front. Thank you.
Good afternoon, ladies and gentlemen. We are in for, I would say, a treat. We have a couple of 5 presentations. One presenter is not here. And these presentations would be looking at a broad spectrum of applications within space, the application of space technology for different, or in different domains, for biodiversity assessment, in agriculture, for disaster risk assessment, and I see a paper on geological application. So we would pray that we can listen very keenly to the presenters and prepare our questions for the end of the session, and then we'll have a kind of panel discussion on the questions that will be coming up from the floor. I see Matalse has joined. You're welcome. You each have 15 minutes. When it's 5 minutes to 15 minutes, I'm going to raise my hand, or I will tickle you on your back, because I'm sitting right here. My chair has disappeared. Okay, so without waste of time, we will invite the first presenter, Dr. Heidi van Deventer. It so happens that she's my colleague at the CSIR and my former PhD student. So Heidi, you'll be getting some further scrutiny from me. Her presentation quantifying changes in the extent of South African extra-marine habitats to inform targets of the Global Biodiversity Framework. Heidi, the stage is yours.
Thanks so much, Moses, and good afternoon, everybody. I just have to double check how this works, is which one goes to the next slide. Ah, there we go. So wetlands are highly dynamic systems, and this includes rivers, estuaries, and inland freshwater systems. I'm sure you may have been in a lagoon, and you tap water from artificial dams. But these systems are highly dynamic, and they change both in extent, and in the case of estuaries, they also change their mouth positions along the coast. And so because they are so dynamic, we still need to understand what the natural ranges and extent of these are across different decadal hydrological cycles between very wet seasons and very dry seasons. So these are poorly understood at the moment. But at the same time, it provides a number of ecosystem services, such as nursery functions for fishes. In the case of estuaries, there's also flood regulation and water provision, especially during the dry season. And despite these being so important, for the past 20 years, the South African estuaries and wetlands have been identified as the most threatened ecosystems in the National Biodiversity Assessments. And globally, we also find that the rate of degradation is much faster than that of forest, and actually the most severe in the world. So the question is, how can remote sensing really help us in distinguishing what is a natural extreme cycle versus those that are result from climate change? So extreme climatic events and their impacts, their risks, how does it affect us and how does it make us vulnerable? And where do we have to intervene to stop the degradation? So the focus of my work is at the moment on estuaries, and there's 3 habitat types located in estuaries that we want to study and report as biodiversity types to the Global Biodiversity Framework. And these include your mangroves, seagrasses, and salt marshes. So you can see from this photograph that these are blue carbon habitats. When they are in a good ecological condition, they can sequester, both in the plants and sediment, the carbon. But as they deteriorate, they release carbon and contribute to climate change. So South Africa is one of the members of the Convention of Biological Diversity, the CBD. And as one of these members, we have to report by 2030 any changes on the extent of these habitat types to the Global Biodiversity Framework. So there's 3 targets under Goal 1 that is important for us. The first one is, can we quantify their losses and changes in extent? And this then also influences the second and third target, which the second target wants to ensure that we have 30% of the degraded extent under restoration by 2030. And the third one is that 30% of the extent should be under conservation by 2030. So to measure this, we need to understand what is available in the country. So the first semester of this year, the German Society for International Collaboration, or GIZ, funded a project through the Department of Forestry, Fisheries and the Environment, and they appointed the Nelson Mandela University under Professor Janine Adams to have a project focusing on the prioritization of areas for restoration of these habitats in South Africa. And as part of this project, we did a remote sensing study on how well can we use the space-borne available sensors. Sorry, this screen is flickering, then I can't see what's going on. So I have to look back. As part of the study, we had a component looking at the Google Earth Engine online computing platform to assess whether we can do an automatic change detection over 4 years that aligns with the national land cover data sets of 1990, 2014, 2018, and 2020, and see if we can actually quantify changes over time. From this, thanks Moses. From this slide, you can see previous work has been primarily manual heads-up digitizing done by people since 2005 using aerial photography or orthophotos. And there's been a very slight increase over that first decade until 2018, when they started putting a lot more effort in the number of estuaries that they need to digitize using Google Earth Pro images. And so therefore you can see that increase over there just before the National Biodiversity Assessment of 2019. However, the total number of estuaries is 290 estuarine functional zones, and only 43% of those have been mapped in this process. Otherwise, less than 10% of the 42 microestuaries have been mapped to date. And the challenge with this is also it's been done by different people, and it's been done for different years as well. So there's not a consistent comparison about how this changed over time. And even in parts of that GIS single layer, you would have multiple years for a single estuary that is overlaid on top of one another to show the changes. So this is challenging. But a number of remote sensing people have done studies in estuaries across the years, and they've used successfully a Landsat Spot, Worldview, Rapid Eye to quantify changes in, or actually just to map the extent of these blue carbon habitats. But this has been for very small extents and not a continuous study across the country, and also no change detection has been done, and it hasn't been done consistently. So we also question then the representativity of these studies of how well are they mapping some of these extents. These extents aren't always very dense canopies, and so even if you sit with a certain 30-meter or 10-meter pixel, you're not sure how dense the vegetation is and representative of the extent. And again, it's random years, so these need to be addressed. So in the aim of our project, as mentioned, is can we map with the Google Earth Engine online available Landsat, freely available Landsat and Sentinel-1 and 2 sensors, the extent of these 3 blue carbon habitats aligned with the 4 national land cover datasets that's been done. On the map on the left-hand side, you can see the green regions were the mangrove regions, where we wanted to split those ones and predict them separately from those areas from the Chilomqua estuary in the Eastern Cape westwards, where you don't have any mangroves present. And after our first iteration, we realized there's a lot of overprediction of our submerged macrophytes or seagrasses, and therefore we had to do another split to distinguish those areas with submerged macrophytes or not. So in the table top right, you can see in the mangrove region, we had 207 estuaries, almost double of the other area of no mangroves. And overall, most of our estuaries don't have seagrasses, and therefore only about 90 in each of those 2 big regions have got seagrasses. So it becomes, and it's also highly dynamic. Sometimes these seagrasses die off as a natural process, and you may not pick them up or see them. So the inclusion of multiple seasons was also considered, because previous work have shown that if you include multiple seasons, it increases your accuracy, both the overall and user accuracy. And therefore, for each year, we included the previous summer season from the 1st of September the previous year, including 1 winter season, and then the next growth season up to the end of February of that year. And mostly for the first one, you can see that Landsat 4 and 5 was available, the next one 5 to 8, and then the last 2 we combined Sentinel-1 and 2 for the classification of 2018 and 2020. Our workflow process was extracting first all the sample points from the available habitat types, and then we had individuals, we were a team of 7 people, who then looked on Google Earth Pro through historical images to go and see whether the type and the position of those points for a pixel-based approach was correct. Secondly, we ran this in Google Earth Engine using a random forest and a 70-30% split. And then lastly, we reported the overall accuracies and user accuracies, defining those as above 70% as being acceptable and others not. But our last step was to convert it to polygons and combine it with the transformed land cover classes, being your mining plantations, built-up areas, and cropland, to avoid those being reported as being blue carbon habitats. So the final outputs are then polygons that we dissolve and report. So just to give you an idea of how the report looks like that's currently with DFFE, we've got 30 classes on the left-hand side with a number of blue classes listed here on the left being the blue carbon subclasses that we've identified, light blue also the freshwater systems that we were trying to separate from these. We had terrestrial systems included as well. And then for each region, we report, so that's the non-mangrove region and the mangrove region, and then for each year, and the subcategories, then no submerged macrophytes and submerged macrophytes. So it's a pretty dense table to try and get your mind around, and we try to color code those user accuracies. So overall accuracy is reported at the top, and the table shows you the user accuracy. So we identified those user accuracies that were above 70% as those that are green, between 50 and 70% those that are yellow, and others are then other coded. So you can see it's quite varied, the response across all the areas and dates. But in summary, to make it easier to see and understand, it appears as if there's an increase in the mangroves, the salt marshes, and the seagrasses from 1990 to date. However, this contradicts what's been found in the field, where a lot of decline and degradation has been taken place. Overall accuracies are 64% for 1990, and not as reliable as the last 3 years, with Lancet of 2014 and Sentinel-1 and 2 of the other 2 years. But we did then a comparative study with the outputs that was mapped for the other estuaries manually, and also a visual check with the experts, and summarize, therefore, which years do we really have confidence in. Overall, if you look at the user accuracies, we don't have much confidence that the 1990 30-meter results, spatial resolution results, are great. Whereas you can see, especially for the mangroves, that they're all above 80% the user accuracies despite the years. And this is quite comparative in extent also to the Global Mangrove Atlas, yet upon closer inspection, we still see that there's narrow extents, not dense canopies, especially where you have cattle trampling and where people are harvesting some of the wood that is completely missed. And this means that it's not sufficient even to use Sentinel at a 10-meter spatial resolution, despite the excellent spectral bands to detect the extent changes or degradation in mangroves. In comparison to the spatial data layer that was mapped through heads-up digitizing, we found the prediction was 151% compared to that. Means somewhere in between is the reality or truth, more than 100%, but maybe not 151% of that extent. If you look at the salt masses, we had 6 classes, and mostly in the mangrove regions, the Juncus crassi presented very well above 78%. But in other areas on the west coast, the succulent salt marshes aren't well represented between. Okay, and so our over-representation was double, 200%, whereas for seagrasses it's 232%, which is completely unacceptable. And we also had a look that these are not in the right places. So there's over-prediction of all the habitats. These are examples of the outputs. Top left, you can see there was also cloud cover that hindered classification after Imphilosy in the 1990s. And just in conclusion, we had some 4% of the estuaries that did not do any classification. We ran it a few times, that didn't work. And then we are busy compiling the 5 and 10 meter contour lines above the coast to see if we can cut back and improve that reporting. But basically, we don't think that the Sentinel-2 and 1 is sufficient at a 10-meter spatial resolution. And there's a NASA Bioscape campaign on 5 estuaries that's looking into improved classification. Thanks to my colleagues, they indicated in the white text at the top.
Thanks, Heidi. Right on time there. With 2 minutes left. But because of time, we will rapidly move to the next presentation, which will be done by Dr. Silence Monremezulu. Silence, despite this number of years, I still cannot get your surname right. I did supervise Silence when he did his honors degree, and I still can't get your name right. So come forward for your presentation on synergetic use of Sentinel-1 and 2 data for wheat crop height monitoring using machine learning.
Thank you so much, Chair and organizers for the conference, and thank you for the opportunity. So my name is Silence Mgomezolo. It's not that complicated. I want to share with you some of the results that we've been doing as part of the bigger project at the ERC. So this is the outline of my talk. So the idea really is to take advantage of the optical properties of Sentinel-2 data, as well as the structural information that you get from the SAR Sentinel-1 data set, and how we can use that information to generate some kind of information that farmers can actually use. So if you look at the wheat crop itself is one of the most important crop that or is used by millions of people, and so the demand of this crop is very high, and is affected by climate change and all other factors, and most recently the geopolitical situations. So all of those factors come into play and increase the prices. If you have noticed, the bread is expensive, almost double the price what it was before, a few years ago. So all these things affects the food security, and I think this is the key term which our opening speakers have also mentioned. So the idea is we can use remote sensing to try and improve crop management practices. So here you have a plot which shows different countries that produce wheat, and also on the right you see a plot that's a bit outdated, but you can see different provinces within our country that produce wheat. Okay, so our study area is located in Clarence in Free State. So the site receives an annual average rainfall of 688 millimeters, and it has a temperature ranging, average temperatures ranging from about 8 to 20 degrees. So we had set up the experiment to follow the crop growth stages. On the table there you see different phenological stages for the wheat, and the red dots just indicate the systematic sampling points that we measured in the field during those 5 months measuring crop height. So generally the measured data sets shows this kind of a nice sine wave as the crop develops over time, and the pictures just indicate us being busy in the field. And the general goal really was to develop a model that is simple and usable, as well as accurate enough. In most cases, with these types of machine learning, you find that the models are so complicated with lots of variables that someone else cannot actually adapt that model and use it. So it's just a model that is too complicated, not easy to use. So we wanted something that was simple to use. So we used Sentinel-2, and we derived the NDVI as well as Sentinel-1, the different polarizations, and we had about 100 sampling points. And we selected random forest and support vector machine, and we validate, our validation approach was to split the data in 70-30 proportions, and we also applied the 5-fold cross-validation method. So here you just see correlation matrix that indicates correlation between the measured height as well as the different variables. And you can see that the vertical and horizontal polarization was the one that had the highest correlation with the height, because it's more sensitive to the structure of the crop during the growing seasons. And you can also see that the model performance, when we used Sentinel-1 and 2, we obtain desirable results compared to if you were to consider using a single platform. So this is the plot indicating the spatial variability of the model height, and you can see areas where we have agreements and disagreements during different crop stages, but in general, the model do provide some kind of acceptable agreement between themselves. And the validation plot on my right also indicate the variabilities between the models compared to the measured height over time. And what you can notice is that towards the end of the season, when the leaves starts to fall off from the crop itself, and the NDVI is low at that time, the models also starts to struggle a bit. But if you have the Sentinel-1 information, those effects are minimized in terms of the estimating the crop height. So at those levels, the optical data itself will really struggle without the Sentinel-1 data set. All right, so these results really provide a farmer with information of a way of monitoring his farm, and he can see the performance of his crop, and he can decide to take actions. This is very, very useful in terms of fighting or improving the food security, as well as the protecting the investments that are being made from the first place. Okay, so this last slides, it relates to the project information. So this project was funded by CSIR and DSI, so we're very grateful. So we continue to work on this project. The goal really is to use UAVs to collect different imageries on different crops, and from that develop models that then can be applied at a satellite level, just like this example that I've given here. And these are some of the research output that we have produced so far in this project, and we have 2 PhD students, Colette de Villiers and Luandile Nduku, which are working separately on different projects also, but within these bigger projects that was funded by CSIR and DSI. So thank you for your attention.
Thank you, Silence, for that interesting presentation. Being, able to map with structural characteristics from drone data, and as you mentioned at the end, that's very important in terms of scaling the mapping process to the satellite level. And thanks for also making good use of the time. Please, we would like to have the audience ask their questions as we move along. You can, on your smart device or computer, log into www.slido.com, and that's the code you can use there to get into the system. And please, you can either choose to be anonymous, or if you're not shy, you can actually mention your name. Okay, so that's the code there. So with that, we will move to the next presentation. And please, I would like to see the questions coming through. You remember in the morning, the DGG did say that we are not in for mediocrity. So let us scrutinize some of the work that is being done. Okay. We'll tackle the questions at the end. Thanks. So let us move over to the next presentation that will be given to us there by Michael Britzke, Unlocking Earth Observation Imagery to Provide Insight, into business. Thanks.
Great, thank you. Moses, thank you very much, and thank you once again for having me here today. My talk is going to be a little bit different from more of an academic approach. I'm on the downstream side, and I'm on the private business side. So it's really going to be more along the journey of Swift Geospatial, how we've learned, lessons we've learned, good and bad, along our journey, and how we've used those lessons and harnessed the power of satellite imagery in order to provide decision support for our clients across the globe. Perfect. So just the presentation kind of content. I'm going to introduce the company a little bit better than what I've just done. Then we're going into some market verticals. Partners are really, really important to us. And then we're going to look at a traditional workflow that we like to use at Swift Geospatial. And in that, lessons that we've learned. So if anybody else that is out there can take some shortcuts, that's better instead of going our route. And then just a case study to end off on with one of our clients, just to see how we've harnessed the data and the results that we give them at the end of the day. So Swift Geospatial is obviously a South African company. We're based in Pretoria. And we started, the doors opened in 2016. So we've just had our 7th birthday now in the beginning of August, and we're entering into our 8th year now. Since then, we've moved on from a tiny little room with one desk, with 3 of us all playing footsie under the table, and desktop machines and everything like that, to now in 2023 and embracing cloud computing, looking at how we can further automate with machine learning, AI, different types of satellites coming online almost on a daily basis. How do we harness all of these different types of satellites in order to still provide an answer for our clients? Where we are today is on our physical side, we have 7 staff members, and then 4 is outsourced, so that's more along the lines of finance and marketing. But the real shift has been in the notion of seats in the bum, or bums in the seats, moving into cloud computing, right? Understanding the flow of satellite information. How can we get that picture that's been taken in space as quickly as possible and process it and provide, once again, decision support to our clients so they can then use that data for whatever reasons that they want to use it with. And so for us, it was a journey that we had to move with different partners. And currently, we're sitting in the AWS environment. We've got 2 dedicated image servers from Esri. We have an Esri enterprise system. And at any stage, we have about 24 ECWs up and running constantly, day in and day out, to provide this type of solutions for our clients. And with the servers based in Cape Town, Oregon, and Frankfurt, all for specific reasons. Not only in Oregon, for argument's sake, is where one of our satellite providers are, so we can get the data quicker and process it there quicker before sharing it. And then things like Cape Town for Cape Town clients sharing data, images, those types of things. The company itself started off like any initial company. I can do everything for anybody. So if you wanted me to come and cut your dog's hair, yes, we can do that. Yeah, we can, right? So we were like a fishing trawler, and we threw the nets out and we caught everything, or tried to. But ultimately what that happens is that you start, 3 people at that stage started to spread themselves incredibly thin as it is, and you start to lose focus on what you're trying to achieve. And so we had to quickly cut loose the nets and try to focus on certain market verticals, which have then shifted from time to time, but basically settling on these types of products and monitoring solutions. So forestry, both commercial and natural forestry. So natural forestry, things like deforestation, burn scars, those types of things. Agriculture, it needs no introduction there. Mining, specifically for tailings dams, illegal mining. Not the Zama-Zamas, that's underground. Satellites cannot help you there. But we're talking about illegal mine monitoring up in Africa, where there's degradation of land that's a lot more visible. And then sustainability is now the main driving force of the last couple of years. So climate change, sustainability, ESG. And that's where the case study that I'll show you is on. So the chocolate bar that you're eating, how do you know where that chocolate comes from, right? Is it sustainably sourced? Do you just believe the writing? Sustainably sourced, and you're happy with that, or do you want to know more? And that's kind of where the GIS and remote sensing, leveraging this kind of this analysis and this imagery, can obviously provide you with those answers. Partners are obviously incredibly important. Also, a lesson learned very, very early. You can't do everything yourself, and there's no need to. And I think that's been in the beginning sessions as well at the conference, that collaboration and partners, it's incredibly strong, and that's something that's gotten us to where we are today. So obviously in the pyramid building, cloud computing is now our base, mapping analytics. On the optical side, the high resolution side, we've partnered with Maxar. Obviously their range of satellites from 30 centimeters, 50 centimeters, 4, 8, 16 bands is really ideal. And then we've partnered with Planet now for over 7 years. So Planet, I'm at a space conference, I'm assuming you know who they are. But in case you don't, 3-meter resolution, 8 band, and they take a picture of the Earth's landmass every day. So every single day there's a brand new picture, more or less, about 70%. And then finally Capella Space, which is a radar company. So that's really something to enable to see through clouds if we want to, at a resolution that our clients would want. So what have we learned along the way at Swift Geospatial is trying to build these 4 pyramids into place. So pyramid number 1, or section number 1 really is data or raw data. GIS, remote sensing, that's the bulk of it. Spatial data, raw data, where is it, what's happening, and can you map it and can you report on it? And so what we've learned on that front is the concept of not necessarily using one or another satellite. Perhaps the solution in itself can be multiple of different types of satellites. So now also think not just your Sentinel, your Maxar, your planets, but you can throw in Airbus, you can throw in the Koreans, you can throw in the Chinese, you can throw, almost everybody's got satellites up there, right? And so each one has its own pros and own cons. So instead of using one or the other, how do we leverage multiple satellites to achieve the goal that what we are trying to achieve on the downstream? And so for us, if we look at your Sentinel-2 image, that provides a certain level of information on the ground. So if we're looking here at commercial forestry, it's great. We can see more or less where the compartments is, and with the spectral bands, we can tell them if it's healthy or if it's not. Then if we move into a Planet 3-meter, the quality, obviously the higher resolution, starts to increase. So now, what's the difference between Sentinel and Planet, right? At this stage, it's really just resolution increase and the return of the satellite. And then if you look at Maxar over the same thing, we have 50 centimeter over the same compartments. But the goal is to say, well, what does the end client want? How do we leverage all 3, or do we even need to leverage all 3, right? Do we try and take the satellite image and massage it into what the output is because the client doesn't have a budget and so we have to use Sentinel, right? Or do we rather take it a step back and advise the client at the end of the day, listen, for what you need, Sentinel is good enough, and actually you don't need to waste your money on other things. Let's just focus on Sentinel. Or is it a case of using all 3, right? So in a very crude example here with the commercial forestry, they want to understand if their compartments are healthy, and they want to understand how much harvesting is taking place, right? That's it. Simple questions. Often they are just simple questions. And so Sentinel is very good at telling you those 2 things, right? There's my compartment, the trees are still standing, the NDVI is still high, there's no harvesting, and I can get my health. But if the client is maybe after a little bit higher and bring down the accuracy, then you want to have something like a Planet now where it can tell you the percentage is a lot higher of what's been harvested and what's not been harvested. And if the client wants those updates on a daily basis or every second day, then once again, Planet is your best fit for that solution. However, if they want to count trees, you can throw Planet out of the window because we don't need now Planet. And now we need to focus on your high resolution, your 50 centimeter, your 30 centimeter, or drone data. So that was a lesson when we initially started, and we just try to bring everything into one client space, and we try to always make it fit instead of actually taking a step back and trying to educate the client into saying, this is actually not going to work for you, and you need to go this route. Yes, it's going to cost a little bit more, but this is where you need to be, because in the long term, you're going to get a return of investment sitting over here, right, with purchasing of satellite imagery. So that was something that we learned along the way. And then another little kind of tidbits of now the second silo, really, of the data, but now measuring, how do we improve efficiency of measuring the data, of providing the data to clients. And so initially, I suppose, like anybody here, and maybe still lots of us sitting here, still with your desktops on your laptops, on your desktop, and you're opening up Arc Pro, or you're opening up QGIS, or Envy, or ERDAS, and you're processing data furiously there. The transition needs to happen. The transition needs to happen from a desktop into a cloud environment. Because as soon as we've done that, we can now leverage elastic computing, cloud computing, and we can start processing big data, large data quicker, and providing those answers to clients quicker, right? So it took us a long time to kind of make this jump, and it's not an easy jump to do, particularly for somebody like me who has no idea what's happening in the middle of that screen. I walk around the office now, and all I know in Python, if the writing is blue, it's bad. Something's happened, the script's broken, something somewhere's gone wrong. So I can see people hiding their screen when I'm walking around and there's blue writing. But I don't know, I'm still like a map and a legend and a North Arrow type guy. But Python and scripting is the way of coding. We're looking at people that are coming out of varsity, and if they don't have those skills, you kind of dropping down the list of the pecking order, because this is where it's moving to. And the reason why it's moving into those directions is because it's more efficient, and you can do things faster and quicker. Not always better, but definitely faster and quicker. And then through our transition into AWS, we also started to realize in the processing and the types of language we were using, how quickly we need to, move on. And so for us, we still use the NDVI. NDVI was used for the first time 50 years ago, right? 50 years ago, and yet we're still using it today. And so for us, a lot of it is still try and keep things simple. Don't always necessarily need to reinvent the wheel. And then now the speed and everything is focused on the sensors, right? How quickly can we get the imagery down? A lot of sensors are all the same, but it's that movement now. I'm just going to rush through here just to get to the case study, but AI, machine learning are all bits and pieces that we've had to learn and take on board. Some of it works, some of it doesn't. But for us, it's still often the human element that tells us the failure, success of a project. We've got cloud masks that tell you if there's a cloud or not, and AI is working on that. I've seen it fail many, many times, but I've never ever seen one of my staff members not be able to tell me where a cloud is in a picture. Right? And so we still need that element. And then at the end, really, it's about the reporting side. How do you share that data with non-GIS remote sensing people? How do you make it simple? Red, bad, green, good. How do you make it accessible in boardrooms and in meeting places that everybody can get access to the data? And not just data scientists, but the regular Joe, and understand what is happening where they need it. And then just to finish off on our case study with one of our clients, Barry Callebout, we were tasked with deforestation monitoring of their cocoa fields across the globe. So it currently covers around 8 countries, covering close to about 1 million polygons, tiny polygons, and the idea is how much deforestation is occurring in their fields or close to their fields. Because if deforestation is occurring at their cocoa, then the chocolate you're eating is not sustainably sourced, and they can no longer buy from that particular farmer. But how do you monitor that? And so really it's about building a complete environment for our end client that makes it simple. Looking at alternate dashboards that everybody can use, can access across the globe on their smartphones, anywhere, and then focusing on what they want to achieve at the end of the day. So how do we tell them how much deforestation is occurring because of them, right? And that's a scary question that they had to ask us. And I'm not going to give you the answer because it's not very flattering. And then from here, really, it's about then that top-down approach that so many people have been speaking about. How do you monitor these massive areas? You use the free stuff first. You then go to maybe a hotspot analysis or heat maps to understand where the most damage is occurring, and then focus on your higher resolution satellite informations. So for us, and the final slide, I'm not going to hold you too much for lunch, is use free data. We've done that. Use a lot of free data that you can get your hands on, verified free data, partners, and then kind of work down the funnel of where you need to be, and then stop at whatever interval that you have to stop at if that's what your client needs. and then work on that, and then every time you do another iteration, try and make it a little bit better, a little bit cheaper, and a little bit faster. Thank you.
Thanks, Michael, right on time there, 15 minutes. And you've indicated quite some important aspects with the kind of work that we do, the issue of scale, mapping at multiple scales, and then you can use a coarser resolution images or images to map at the regional, sub-regional scale, and you can zoom in into some critical areas using high resolution images. That is quite a good recommendation there at the end. We would rapidly move to the next presentation, wildfire emission assessed using remotely sensed data, a review by Lerato Shikwabana, if I get that right. Thanks.
Good afternoon, everyone. I like the last speaker when he spoke about free data. That's what I use all the time for my work. Yeah, so I'm a senior scientist within SANSA, and I'm also an honorary research fellow at WITS. And my field that I'm passionate about is atmospheric science. So I look at everything in the atmosphere. So anything that gets emitted, from wildfires to cars to power stations, that's what I look at. But for today's talk, I'll just talk about the fires, because I like fires more than anything else. Okay. Oh. Oops. Down. Oh, is it fine now? Okay. So why the interest in the fires themselves is that? Okay. So when we burn vegetation, we release carbon dioxide, as we know, and carbon dioxide actually traps heat, and it gets hotter, and the vegetation gets drier. And in the end, that cycle will repeat itself again. The vegetation will burn again, and then, then we get CO2. So I looked at some studies, some emissions trends. Well, that's what the only thing I could find between 2002 and 2019. You can actually see that there was a bit of decrease in the emissions, but going from 2009, that looks to be an increasing trend. Why is that worrying? It's because we know that there are negative effects that wildfire cause, right? So we know there's the economic system damage, you got erosions, and more importantly for me, my interest is more on air pollution, because that directly affects meteorology, meteorological parameters that you'll find. And also, if you have these greenhouse gases, that even makes it worse in terms of climate change. So I also went to the literature and looked at the fire counts globally. So there's a few culprits here. That's always like burning stuff. And Central Africa, in the DRC, we know that there's annual fires that occur there between around July and August. And then also in the Amazon region, there's also some big fires. So why we're interested in the fires again is that if you look at this graph here, these are mortalities, number of deaths that are caused by fires, well, smoke and particles and aerosols that are released by these wildfires. Okay. So going to the data that I'm excited about is that, free data, like I said. So these are some of the data sets that I use for my studies. It's not everything, but these are my best ones that I like. So MIRA2 is reanalysis data. So this is data that comes from the ground and also satellite, and it gets merged together. And it doesn't have the greatest of resolution. Oh, oops, sorry. I need to go back. Yeah, it doesn't have the greatest of resolution, but it can give us, the data is continuous. So it means there's no gap in the data itself. So we just get a sense of what emissions are there. And then there's tropomy, which is the latest sensor, well, instrument on the Sentinel-5P. The resolution is the greatest that we have at this point, and the nice thing about it as well is the temporal resolution, so you get 1 day measurement. And then I'll move on to my favorite one here, which is Calypso. So Calypso is a space-borne LiDAR. I actually have a picture of, a video of that. So this is just an animation that was created by NASA, basically demonstrating how Calypso would sort of take measurements. So here they were just showing how dust from Africa, near Sahara, leaves Sahara and goes over the Atlantic to get to the Brazil regions. So the beauty about Calypso is that it could give you these vertical profiles. So you can actually tell how far your particles are. And this is not just limited to dust, so we can measure biomass burning aerosols from Calypso. But also we can also get the spatial distribution of how the particles are situated. Let's see. Okay, so there's also, we can also do some seasonal studies here. So if you just look at that, okay, I'm gonna move on, sorry. Yeah, okay, so there's a number of studies that I've done with my collaborators on wildfires within South Africa and also Brazil. So this is a paper we published in, I can't remember, when was it? 2001. What we were looking at the sugarcane burning in the KZN and in Mpumalanga region, which occurs every year, right? So what we're seeing here is the vertical distribution of these aerosols. So this was taken from Calypso. So these are elevated smoke. So the smoke can actually get to about 6 kilometers in altitude. And also we looked at how the trend itself, how the biomass burning has been, behaving. Well, this is MIRA 2 data, the one that told you that it doesn't have gaps, and it starts in 1980. So you can actually see that every year we're releasing a lot of black carbon to the atmosphere, SO2 and carbon dioxide through the burning process. Okay, so this is just the spatial distribution of the particles themselves, the black carbon here, as you can see. These are also seasonal. So we know that during the winter period, that's when we see a lot of burning happening, and that's why we see a lot of emissions, black carbon or otherwise. And what you're seeing here is the high split model. So what the model basically does is that it uses MSs to tell us how far or where these particles are distributed. So in this case, we can see that they're actually going south. And these are also seasonal. So I just used the winter and the spring just for illustration. Another study we did, which was quite interesting, was the wildfires in Naisna, 2017. So we used Sentinel here to look at the smoke that was emitted. But most importantly, we also looked at the vegetation that was destroyed during that event. We also looked at how the particles traveled once the particles are released. How do they travel in certain days? So this is what we're seeing here from the high split model. So also this work was published in 2009. Okay, I just thought I'd add that fire to show you what I mean. So this is so this was the Naisna incident where a lot of buildings and vegetation was destroyed. Okay, so what was also interesting was the Australian fires that occurred in 2019 to 2020. So we also looked at, let me see. Yeah, so we actually looked at a month. What do I do? Okay, so we looked at the emissions. This is tropomy data. This is a tropomy satellite. We're looking at carbon monoxide in December and in November. So you can actually see the spatial increase in terms of the fire itself and also the emissions. And now this is the Calypso data that we took. So as you can see, when it crossed over in the Australian region, we could now measure locate where the smoke and the aerosols are. So there were well, these were quite a big fire. So you can actually see that there were aerosols and smoke over 10 kilometers in altitude. And then Calypso can also tell us about the type of particles that you're seeing. For example, in this case, black would be smoke, and brown would be your polluted dust, which will be like your black carbon. So we also use some other data set. This was the fires in Amazon in 2019. So actually wanted to track how, when the particles left this burning area, where did it end up? So we use the flex, we call it the flex path model. So we take the backward trajectory. So we start where we want, and then we go back. And we could sense that actually these particles go to South Africa, and we also had stations. We've got a station in Cape Point where we actually measured the CO somewhere here, yeah, in Cape Point. Yeah, so this was just for the carbon, the backward trajectory. And then almost done. So this was an interesting study that we also did during the lockdown, where we were home. We don't know much what to do, but yeah, we started this paper with my colleague because we wanted to see, because we were always studying these fires, especially around the African region. But we wanted to see if there's an effect, you know, or if the lockdown had an impact or effect on the burning itself. Yeah, so it did. A little bit. Yeah, so when we, it did. So what we concluded was that people were not working. Oh, sorry, I'm not working. So in our argument, we said that people were not working. So people were at home, and especially in those regions where we know it's quite, people don't have a lot of, I don't know, money is the right word, or jobs. So they resorted to other ways to survive. And we could actually pick it up from that little point here, where the 2019 was, where there was an increase in the CO. But we can debate that. It's cool. Yeah, some mitigations. In fact, I don't know. Let me just get to my main findings. So yeah, so my main findings are that satellites obviously are the best instruments to use in my study, you know, because the data is always there. And also, we noticed that emissions can travel long distances. But what we need to study now is when they get to that place where they sort of settle, what contribution do they have on quality and also on the meteorology of that part of the world. And yeah, and big fires can go up high, eh? So smoke can get to 4, 6, and 9 kilometers, which is also another science on its own, because they react with other pollutants or that are up there. So, but that we still have to figure out. So the gaps, still need to learn how to use machine learning to predict this fire currents and the detection. And also, emission patterns are quite important for us. So we went to literature and actually saw that, so there's a lot of work that's been done now. You can see the increasing in terms of machine learning, applying it to wildfire detections. So we're quite excited about that, and let me not say much. So I want to thank my collaborators here. So these are the guys that I work with for this work. Mashat is going to talk next, and then there are some other great people that I work with as well. So just 30 seconds. I wanted to tell you guys about this project that we did, the Biomass Burning Aerosol Campaign, which is called the BBAC. So that was last year, around October, I think. So what we did is that we got a whole lot of instruments from various institutions. Those collaborators that I showed you. So everybody contributed towards an instrument. There was the LiDAR, there was the sun photometers, there was some, so we released some balloons there with the ozone ascent. And so these are some of the instruments that we use for that campaign. But we still have to analyze the data. It's a lot. So we need some students to get into that project, help us to get through that. Thank you.
Thank you very much. I think as you take your seat, my question really is all the burning around the world, who suffers most from, or which country suffers most from the burning in the Arctic, in Russia, I mean, it's crazy. But from the vantage point of satellites, we can monitor the emissions from fires. That's very interesting. So please keep your questions coming in through the Slido platform. The speakers will respond to the questions at the end of this session. Now, the next presentation would come from Matlatse Kayango. A very interesting title there, Music and Bands. Matlatse, music always goes with a band, right? Yeah. Okay. So optimizing Sentinel-2 future space for improved crop biophysical and biochemical variables retrieval from using the novel spectral triad feature selection algorithm. A lot of novelty in this presentation. We're looking forward to it.
Thanks very much, Chair. Thanks very much. Good afternoon, everyone. So I'm going to be presenting on this topic. Just a disclaimer, I don't own a band, nor am I a musician. So the contents of my presentation, I'll go through the background, the objectives, and I will introduce why we are combining music with the bands, and present some case studies in terms of the tests of the algorithm itself, and summary and conclusions, as well as the future works. So those who know algorithms, they will know that over all the years, algorithms, most powerful ones in particular, are inspired by nature. And one of the most popularly known algorithm is based on the decision trees, where the person who came up with it, I don't know, maybe they were sitting under the shade of a tree and they thought, wow, maybe this will be a good decision-making algorithm. And they developed what we call classification and regression trees, and later it evolved into what is now known as random forest, a very popular algorithm. So also, there is an algorithm called artificial neural networks, which is based on the human brain and how our biological systems are working. And this is one of the major drivers of what we call today artificial intelligence. There's also other algorithms that were developed based on genes and how they operate in our bodies and so on. All of these algorithms were inspired by nature. So in this presentation, I'll be talking about an algorithm that is inspired by music. So when I was still growing up in my university days, I used to sing in a choir and at some point read a lot of music books. But of course, I started very late to become a musician, so I gave up on that. But the knowledge I gained at the time visited me while I was still doing my PhD, and hence I had to come up with something novel to demonstrate my capability and my deserving of a PhD, I guess. So the objectives of this study was particularly focusing on optimizing the retrieval of biochemical and biophysical variables of agricultural crops using feature selection techniques. So we did this by identifying and selecting relevant remotely sensed covariates from Sentinel-2 data. And why do we need to optimize the data itself, or the variables that are included in the modeling? This is one, to improve the accuracy and the reliability of the results. So these are the two studies that we actually got the motivation from, where actually they found that you only need about 4 to 9 bands for estimating biophysical parameters such as LAI and biochemical parameters such as chlorophyll content in leaves and canopy. So in order to achieve the objective, we're proposing a novel spectral triad feature selection technique, which is inspired by music theory. And we compare this to existing algorithms, such as the recursive feature elimination, which we coupled with the popularly used random forest algorithm. And also, we compared to a situation where we use the entire, all the bands of Sentinel-2 to see what are the accuracies and errors when we compare with that, with our technique. So we also assessed the consistency between the selected feature subsets between all these different algorithms. So just to introduce what we were actually doing here, or how the whole theory about the music and how it is inspired this algorithm. So in music, we have what we call a chord, which is a set of notes played together at the same time and to make harmony. In this case, we are using what we call a major chord because it has a specific pattern where it's 1, which is the root note, the starting note, and then 3 and 5. So the third and a 5th note played together on a diatonic scale. So the intervals of the major chord, those are the spaces in between the chord itself. We use that because they remain the same regardless of the root note. So regardless of where you start to play the piano, the chord, the root note or the chord itself remains the same. The pattern remains the same. So this ensures that there is a maximal separation between the half steps between the other keys across different octaves. So in the context of this algorithm, the interval ensures that the triad, which is the chord consisting of 3 notes, actually consists of spectral bands that are very separate from each other, hence to avoid collinearity in the evaluated triad. So the algorithm, as I've mentioned, it uses major triad chord formula, which is 1, 3, 5. It represents the starting variable, which we call root note, Rn, in the algorithm, and the third and the 5th variables. So if you have a Sentinel-2 data set, you select if your root node is 1, you start from the band 1, and then band 3, then band 5. Combine those to form a chord. So the root node, as I've mentioned, then in the data set is an index of the explanatory variables in the data set, which is default by 1, but within the algorithm can be controlled by the user. Then the octaves are the search iterations. So it's an iterative algorithm and goes through the data sets over and over again looking for these different chords. Sorry for too much text. So once we form these different chords, we use what we call an evaluation criteria to rank the variables within that specific triad or a chord. Then the best variable is set aside, and the algorithm will continue looking for the chords across the entire feature space or the entire data set until it finds all the optimal bands. And from then it will perform some regression analysis to determine or to estimate the biophysical parameters. The algorithm is meant to actually reduce the dimensionality of the data set as well as the collinearity between the bands. As you know, Sentinel-2 has many bands, particularly multiple red edge bands, which may be collinear depending on the situation. So this is the outline of the algorithm. You start by the number of covariates, then you choose a root node. Based on the root node, then we can be able to easily select the third and the fifth nodes, which is the variables in this case, and then we evaluate the relationship among those variables using either a filter-based algorithm such as the relief F, or within a wrapper mode. Wrapper mode basically means you're coupling a feature selection algorithm with a regression technique. So in that case, you can use a multiple linear regression or random forest or any other algorithm that you choose to combine it with. And then the evaluation criteria will now rank and select the most significant or influential variable within the model. And then the one with the lowest p-value or highest importance score will be set aside. This is repeated until all the triads in the data sets are actually evaluated. So this is just an illustration of what I was talking about. Say you have a data set, sentinel bands, then if you put that on a mental piano, we are able to select the root node, then the third and the fifth, and this is just the structure of how the algorithm will go around the data set, searching for these different triads. And once for each of these triads, then it will use the evaluation criteria and rank them. And the top one is the one that is going to set aside until you reach an optimal subset of the data set that you're looking for. So the tests were performed in Bothaville, in the Free State, where the main crops are maize, beans, peanuts, sunflower. And this is the outline of the methodology. We had Sentinel-2 data with in-situ data. Then we have the spectral bands. Use cross-fault validation within the recursive feature elimination, which is a well-established algorithm. We have the spectral triad feature selection, and then a situation where we just use the entire set of the data. And once we get the optimal subsets, they are subjected to random forest regression. Then through cross-validation, we are able to validate our model. So as I've mentioned, the algorithm can be run in two modes: a filter mode, which doesn't consider the variable you're estimating, just the relationship among the different variables, and the wrapper mode that considers what you're estimating into the feature selection. So these are some of the results. I think I forgot to put the maps as well, but from what, I don't know if this is visible, but we got R-squared that is similar to a well-established algorithm, which is the feature selection, recursive feature elimination, although it is higher, but our results came very close to it. Also for the leaf area content, leaf chlorophyll content, actually our results were slightly higher, and for the canopy chlorophyll content, the recursive elimination was just 1% higher than our results. And if you compare with a situation where we don't do the feature selection, the feature selection is actually beneficial, and yeah, our algorithm was performing in consistency with the existing algorithms. So in conclusion or summary, we're proposing this spectral triad feature selection for optimizing the feature spaces of quasi-hyperspectral sensors, such as your Sentinel-2 and Wellwood-3, which contain a number of bands which have a potential to be collinear. And collinearity affects the machine learning performance, so when you're doing the estimations of these biophysical parameters. So this was benchmarked against the recursive feature elimination as well as the entire data set, finding that our method performs similar to the existing methods, but better than when you're using the entire data set. Overall, the results showed that the Sentinel-2 data could be optimized through feature selection, which result in slightly better results or equivalent results. Also, the spectral bands selected by the algorithm that we are proposing were consistent with the ones that were selected by the well-established algorithm. So the current work that I'm doing now is to develop an R package so that we will release this algorithm to the public and other people can develop further on it. Thank you very much.
Oh, thank you very much, Dr. Kayango. Feature selection, a very, very important aspect in remote sensing. Don't just throw all of your bands or all of the bands into the model. You need to select the most important features or channels and use them in the model. And you've added a new algorithm into the set of algorithms that we have. I think I should be trying your algorithm after I leave this stage. And we look forward to seeing papers on using the triad feature selection algorithm on hyperspectral data. That would even make it more interesting. Okay, last but not the least, presentation this afternoon will be coming from Didiza, and she will be presenting on remote sensing in assessing engineering risk, using satellite data to detect ground settlement and swelling for planned railway infrastructure extension. Thanks.
Thank you.
You're welcome.
I am so tempted to say, let's jump to lunch, and we can have this presentation at our booth, at Khotatso Innovations booth number 10. Good afternoon, ladies and gentlemen. So I'll start basically just outlining what I have for you today. And really it is starting from just introducing who Khotatso Innovations is. I actually had quite a few people come through the stand and says, who is this Khotatso Innovations? We've never heard of you. So we'll cover that a bit. And just to also give you a background in terms of this project that we did with this particular client, and then obviously how we went about it together with the team. And then just to share as well, maybe some IP that we are happily sharing as private sector, to say where some of these application areas are. Just to share as well, I am wearing two hats during this conference. Besides being the director for Khotatso Innovations, I'm also the co-chair for the Agriculture and Food Security Community of Practice. I know that came up quite a lot, food security, in the previous presentations not too long ago. Just briefly, Khotatso Innovations, been around since 2009, officially, practicing and consulting in 2015. Our focus really is engineering, environmental mining, and also do quite a bit of work within the public sector. And I'm mentioning this because as we offer GIS and remote sensing, we're also saying that, we need to speak to the people that look after our natural resources, our infrastructure, and that's where we come in to assist. I'm proud to also share that as an SME, we've successfully done over 151 assignments within these disciplines, and proudly also to say that mostly have been repeat clients. So I think we do know what we are doing. And of course, the company is a level 1 BE contributor. Still a very small player within the space. And just to share briefly the structure, again, we are still quite a young team. Mostly myself. We have the remote sensing head who actually did quite a bit of this study that I'm going to be sharing with you. We've had a lot of mention around AI and machine learning. We have our developer in-house. And of course, a GIS practitioner that helps us when it comes to especially public sector projects where you do need to have a GIS practitioner to sign off. And essentially, ladies and gentlemen, what we do is to really understand what the business problem, before we say, is it a GIS kind of solution, or is it a remote sensing kind of solution? And in some cases, you might find that it's actually both, as you may understand and appreciate that these two technologies actually, fall under the geospatial, kind of domains. So we would normally start with, consulting and getting to understand, and then advise the client based on that. So this particular project, some of you, I'm sure most of you are quite familiar in terms of the how train that we use on a day-to-day to travel. And really in this case, I know there's been a lot of, studies that have been done, feasibility studies, where we hear about the how train going to be extended to other areas within the country. So this is one of those studies where our client in this case was asked to do, a feasibility study in terms of exploring, the route options that could be considered in terms of extension. Now remember, a lot of areas within Gauteng, the ground conditions are quite risky, and they need to be quite assessed, quite well before any kind of infrastructure can actually go in there. So normally my maps, my slides would normally have a lot of maps, but I will not be sharing exactly the exact study area, because there's still quite a bit of, this is a feasibility study, and the client who was very kind enough to allow us to share the project did say that we cannot share that information at this stage. But of course, this is something that will later on, within time, be out in the public domain. So what happened in this case in terms of doing this preliminary route alignment study was that the Gauteng Management Agency then hired our client, an engineering firm called Hatch. They're very big on the infrastructure side, to basically get them to actually do the study. The areas that Hatch had to actually consider was Little Falls to Jabulani, Cosmos City to Lanseria, and then Cosmos City to Samrand. And really, what the study, really is about is to investigate the alternative options. I mentioned, in terms of the risks that are associated with ground conditions, it is quite good for, an engineering firm with such a reputation to really do their homework. That's actually one of their manifesto, to say that we're bringing in the technology so that when we're assessing the risk, we've basically covered all ground. So in fact, my client came up with a very interesting term for the work that they asked us to do, which was geosensing. So if you do hear geosensing quite a bit, my client calls it geosensing, so I will also call it geosensing. So those were the kind of investigations that they then asked us to do, and really this information was to help in terms of advising what kind of options they can consider based on the risk that's actually present. And then just briefly, so when we talking about, so that's when we were then contracted by the client to say, can you assist us in terms of this geosensing? And that's really to look at, what is the risk in terms of the ground conditions within the areas that they are looking at. And really, so in terms of the study, we refer to the term surface subsidence. A lot of times we don't know and we cannot see what's happening on the surface, with our naked eyes. Hence, we have, this Earth observation data. There's been quite a lot of talk about Sentinel data and how it's been used on various applications earlier on. And really now we were asked to also, do the same. But in this case, we needed to basically to understand how much the ground has actually subsided. Because there's sinkholes, there's dolomite. If you're going to be putting railway infrastructure there, you need to know what the options that you actually have. And really, so some of the causes for surface subsidence, as you may be aware, one is groundwater extraction, especially when it's in excessive amounts, because what this does is then, create a drop in the water balance, and therefore makes the ground to actually, sink. And then there's also the construction that we see around us, you know, quite a bit. And in some cases, we have seen whereby the underlying ground studies have not been properly done, and yet heavy construction buildings are going up, and you know, there's that risk there as well. Your technical guys will share a bit more on those kind of issues. And then, of course, mining activities. We mentioned the zamazamas here. We don't see them, but we see the impact, or something happens, but we haven't actually been able to assess where these areas are. So this is some of the reasons for actually that can result in surface subsidence changes and risks. So what was the client Hatch asked to do? They needed to know where has the ground basically swelled, and where has it actually subsided. And that's where, along, of course, these routes that are being considered, so that now that advises the kind of options that they would then have in terms of this development. And then, so really the objectives, one was to investigate whether the swelling or you know, subsidence had actually occurred within those areas that we were looking at, and also to assess how much of it has it actually, how much subsidence or how much changes have happened in terms of the ground conditions. Now, I'm not an engineer. My role is to share and do the study, together with my team, of course, do the study with the client and share the information. Because how do I know how much is too much swelling and how much is not? But I'll share a bit more on our results a bit later on. And of course, this would be then the information that would be used in terms of supporting the decision-making around which route options can actually, you know, be investigated or even considered. So on the methodology side, where our team was quite excellent, you know, the data that we used was Sentinel-1. I will not share too much in terms of the kind of data that was used. I think what I'm trying to share with you today is a practical example where we are saying that, you know, the application of Earth observation data can actually go as far as engineering and industry, or rather a field where we normally feel that there isn't enough scope for us geospatial scientists within that. So if you see there, again, we've just covered most of Johannesburg. We can't exactly share the actual area. We're looking for the last 5 years, which was 2018 to 2022. And then briefly, the methodology was to develop a model which would be able to then detect the kind of deformation that has occurred. Again, this is where the team put together, you know, wrote a script that was able to actually process the data and do that kind of assessment. So just briefly on the results. Again, this is the wider area that you are seeing in front of you. The red would be the areas where there was immense, you know, subsidence. So those would be your minus values. And then moving on to the blue, which is now where the ground has actually swelled, and the green is where there wasn't really that much of a change within those areas. What we did pick up was that, in terms of the results, was that we identified that there were actually 7 zones within the corridors that we were looking at that we would then define as high risk, because that's where most of the changes occurred in terms of the actual subsidence and even the actual swelling. So we then defined those as zone 1 to 7 so that we can highlight them to say, you know, these are the areas that need more of your attention. So in this case, looking at zone 1 to zone 7, we saw that the surface subsidence changed from 1.1 centimeter to about 3.2 centimeter over the year. So with us having done the study over the months from 2018, we then also did, of course, the accumulated you know, assessment for that period. Now again, is 3.2 centimeters significant? I do not know. And then also we did find that zone 1 to 6, there was quite a bit of subsidence that happened between the area that we were looking at. And then that all the zones studied experienced homogeneous subsidence in late 2018. And you will see on the graph that is in the next slide, there was quite an uplift in 2019. And then after that, things sort of, were quite consistent. What we also did see was that zone 6 had the highest annual average when we're looking at it accumulatively. And then that's when now we then say to the clients that, they would then need to do further investigations on those actual zones that we've, on the 6 zones that we've actually picked up. So what's in front of you there is where we've now plotted the various zones. Remember, we are assisting here for them to identify where the risk may be. So these are the values, the minus being where subsidence happened, and of course swelling, the positive values is where I beg your pardon, is where the swelling happened, where you see the positive values. So where can this kind of study actually be applied? Once again, illegal mining activities. I think it's everyone's problem. And we find that, within this technology, we can actually do some type of monitoring. Yes, in instances, you cannot stop it. But there is some kind of monitoring that you are able to now say, these are the changes that have occurred. Why all of a sudden is this area, why is there the subsidence that has occurred within these areas? Could it be possible, collapsing off the ground underneath? I've touched on the infrastructure development, where we're really seeing quite a lot more applications in terms of space technology within those to say, these are the areas that you need to be careful of or where we need to actually do more investigations. Sinkholes, I've mentioned that once again. And of course, the one which many of us don't like to hear about because it affects our pocket, the insurance industry. Ladies and gentlemen, thank you. I would like to acknowledge my colleague, Mr. Pilar Sibanze, who's very quite known within this room, and also, of course, our client and our end client, the Gautrain, who have allowed us to actually share this presentation with you today. And then just lastly, before I get chased off stage, this is what our client had to share in terms of the work that we did. Thank you.
Thank you, Indelisa. We want to utilize technology during the planning. Oh, that has disappeared there. Oh, the client seems to be very happy there. You just reminded me of my geology lessons way back in the 80s, that if it sinks somewhere, it's going to rise in some other place. Isostasy, if I can remember the terminology for that. And that's very important that we can map that phenomenon now using remote sensing. And so all of us, property owners and those even wishing to buy property, can actually make informed decisions. Very, very important. So can we give all our presenters a big round of applause there? They've done a pretty great job. Now, we are hungry. I must confess, I'm standing here, I'm shivering already. But we will not let our presenters go without at least getting a feeling of what the audience think about the various presentations through the questions they've asked. I will just rush through the questions that we have, and then each of you will take 2 minutes to give a rapid response to the questions that are directed to you. The system is a bit complicated for me, but let me... Okay. So I would just call the names, and so there's a question here for Michael. What are the most important skill needs in this sector in South Africa? For silence, what is your take on the case of drone use what is your take on the ease of drone use in South Africa in the agri sector? So how easy is it to use the system? To Dr. Shikwambana. Shikwambana there, is the Calypso data ready for analysis or needs to be pre-processed? If so, what kind of pre-processing is required? To all of our panelists, how can we enhance collaboration across institutions on these products and services and development techniques? To Lerato there, please comment on how you handle scale issues. I saw you working with multiple resolution data. Matratse, wow, interesting. To Heidi, did you resample Landsat and Sentinel to the same resolution? What do you think about, do you think the impact of spatial resolution was on the accuracy? To Heidi again, have you considered drone technology to collect data where there are gaps? To Michael, did you bootstrap or did you rely on funding from local agencies? To Dr. Kwambana again, if the data use is not of the best resolution, wouldn't that affect the accuracy of the results? And again to you, how can one access the Calypso data? And so many questions directed at your interesting presentation. Do you only concentrate on diffuse sources of pollution or look at cumulative effects? Lerato, sorry if I missed this. Which classification algorithm did you use in your research and why? Silence. At the ARC, are you only focusing on crops or there are some drone projects going on? And if any publish taking into account UAV is new in South Africa. So are there any other applications at the ARC? To Matratse, have you tested the algorithm on hyperspectral data? And there's a question here again to Shikwambana. Why is there no record on Canadian wildfire? And to Matratse, is triad good in dimensionality reduction, or you had other techniques used? To Delisa, how do you think? How do you then differentiate between subsistence and eroded formations? And is triad good in dimensionality reduction, or you had other techniques? I think that again to Matratse. Okay, we'll start with Heidi. You got the questions directed at you. Brief response to all of them, please.
Thanks. I've got 2 questions to answer. We didn't resample Landsat from the 30-meter spatial resolution. We used what was available on Google Earth Engine, and the resampling of the panchromatic band to 15 meters wasn't available, and we didn't resample it to 10 meters. We wanted to test whether the 30 meters is good enough, and we've proven it's not. And we've also proven that Sentinel at 10 meters is also not good enough. So resampling is not going to change those findings. And then secondly, the question was about using drone technology, and I'm very glad for that question because I didn't get to it in my talk. So we had discussions with Ezembelu KwaZulu-Natal Wildlife in trying to see in the Mfolozi floodplain, during the drought years, you can see the transformation. The forested wetlands are cut down, and they change to commercial banana plantations. You cannot actually take the drone up to that point because the license that they have is for 500 meters from the road, and the Mfolozi is much wider than that. So you need a non-visible license, which they are training for at the moment. But the main point is we need consistent, repetitive, comparable images and not random drone images that's taken by different people. We need a consistent approach in comparing natural changes and tipping points. And then, similar to what Michael was highlighting, where you see the problem, then send in the LiDAR drone. Thanks.
Thanks. You can hand the mic to Mike. Michael?
I have two questions. If there were more, you can grab me at lunch. The first one, skill sets, was the question. I briefly mentioned, I think for us, it also depends where you want to fit into the organization, but coming out of students that I see coming out of tax, that's where I've got the experience from. I would push for coding, scripting, big time. That's a skills shortage, developer, those type of skills. But then also on the flip side, for me personally, I think soft skills are lacking massively. And so just being able to stand up and talk in front of people, interact in front of people, very difficult to sell a product to a client if you can't talk to them. And then funding, I wish that would be ideal. But no, we've got no funding FAB locally or anything like that. It's all self-funded startup company. Yeah.
Thanks, and so many questions to Dr. Chikwambana. Lerato, please, can you take on some of the questions?
Okay. Oh, yeah, so there was a question on Calypso being pre-processed. So you get 3 levels of the data. You get the raw data, which is level 1, and then you get level 2 data, which is sort of pre-processed, and level 3 as well. And then for, I don't know if it was an accuracy type of question, right? But for Mira 2, which I said is reanalysis data, yes, you can use it for very small scale. So if I'm doing a global study, that's accurate for me. But then if I want to go down to Alexander and use that data, then it will be too coarse. Like I won't get anything out of it. So I might just say as well, Calypso is dying out. So it's got 2 wavelengths. It's got the 532, which is the green, and the infrared. So the laser has been there since 2006. So yeah, so NASA is in the process now, of commissioning another LiDARs, well, something similar to LiDAR, but even better, with more than three wavelengths. Because what Calypso cannot do is tell you what this gas is, for example, right? But it can tell you that this is an aerosol. So with at least, we call it the dual dial LiDAR, where you have 2, I'm going to get too technical now, but yeah, where you send out 2 beams, one absorbs, one comes back, and you know exactly what you're looking at, what species you're looking at. I don't know what else was, so many.
Yeah, okay, I think we can leave it there. Thanks. Silence.
Thank you for the questions.
Use of drones, and what else do you do with drones at the ARC?
Yeah, so I think the use of drones within the agricultural sector, it's exciting field. Is getting young people to be excited about agriculture. And just to highlight the challenges, you can't just buy a drone and then you fly around. There are all these trainings which you have to go through. Also, the other challenge is handling of that data set. So remember, you have a camera that has geospatial information there, and how do you extract useful information from those images if you are not trained? So there's a lot of work that needs to be done to support imaging farmers, especially to use that data and to be able to extract that data from the UAVs. So from the ERC itself, we have different applications, natural resources, just to be broad, where we apply UAVs. Thank you.
Thank you very much, Delisa.
My question was, how do you then differentiate between subsidence and eroded formations? So what we did with those 7 zones was to also bring in the aerial imagery and actually get to see what has actually occurred within that specific hotspot, if I can call them that. In terms of erosion, was the construction and all of that. So that then advises us as to, yes, it's actually ground subsidence, or it could have been, because of another reason. Thanks.
Thanks.
Yes, thanks very much for the questions. Have you tested the algorithm on hyperspectral data? Short answer, no. Long answer, what I presented today was just a subset of my PhD, and even during my PhD, I couldn't even cover all the questions, but it's something that is in the pipeline and also open to share the algorithm as well for anyone who's interested to test it out before it even gets released by R. Another question was, is the triad a good dimensionality reduction? Have you used other techniques? Yeah, we only used recursive feature elimination as a comparison method because it's one of the state-of-the-art feature selection methods. But anyone who's wanting to test more other methods against it, we are open to also share that information. I think there's another question that was to all panelists, how can we enhance collaborations across institutions on these products, service development techniques? So this is a hot one. So there's no institution, in my opinion, that is existing in isolation and is standalone. Otherwise, you are doing work that is not serving the society at all. So I believe that there needs to be some cross-pollination between different institutions. So in academia, we have a lot of time to play around and do research. We have resources such as students to do the manual works and have time to learn, or they're actually required to learn as part of their programs. And we generate a lot of knowledge, new algorithms, new applications, and so on. But in terms of scaling up, I think organizations, such as SANSA could be involved, a lot of application scientists, the CSRR, and so on, could be involved to take up the knowledge that is being built in the universities, to scale it up and do further tests as well with the universities to do validations and so on. Then the private sector now comes in also then to commercialize these products and services because they know the markets, they know the business side of this kind of work. So this is how I view it panning out. Thanks.
Thanks. I think, Master say you're helping me to kind of round up there, ending on a very good note, encouraging collaboration between us. We shouldn't work in silos. The universities and research councils and private sector should collaborate to encourage the use of space tools and algorithms and so forth for biodiversity assessment, to promote, or enhance agriculture, to ensure food security, for air quality assessment. Even the least expected topic was using Sentinel-1 to assess swelling and subsidence or sinking of land in Gauteng. That is very interesting. We hope we can see that data and those maps on the internet so that we can all pay attention to where we want to buy or construct. So with that, is there any word from you? Okay, I think you will send us packing from here so we go have lunch. Thanks.
Thank you so much, everybody. Thank you so much to Dr. Moses for this awesome moderation session, and to all our guest speakers. Sorry, I cannot pronounce the name. We'll be handing over the gifts, and from there I will announce where the food court is. Thank you, ma'am.
Yes, thanks. You can.
Dr. Shotu, please.